Good day, viewers all over the world. My name is Dr. Chris Esekaibe. I am a chief lecturer in one of the most prestigious polytechnics in Nigeria. I work in Nigeria. I also live in Nigeria. I am the owner of this YouTube channel where I teach key topics in mathematics and statistics. I hold a doctorate degree in mathematics with distinction, a master's degree in mathematics, and a bachelor degree in statistics. I specialize in numerical analysis, data analysis and modeling, scientific computing, and applied statistical analysis. Today, I will be bringing us a topic in numerical analysis titled the Lagrange's interpolation formula. We shall be looking at the uses of this formula and the application of this formula. Beloved, if you are a research institute, you do a lot of statistical analysis or mathematical analysis, you can consult me to be part of your team of mathematicians and statisticians. If peradventure you are an AI firm, you also train AI models to understand mathematical algorithms. You train them, you can contact me. I have been privileged to work with 2 AI firms in the United States of America where I assisted in training their models. I created prompts to storm or break the models. I also created rubrics, chain of thoughts, and golden responses for training this model. I'm also an expert in that. I'm an applied mathematician, an expert in AI training of models. So please, I'll be looking forward to hearing from you. My contacts are here on the board. My first contact is for call and WhatsApp, +234 80 And then my second contact is for call only, is +234 7066 297535. My email is chrisdavid2015@gmail.com. If peradventure you are also a postgraduate student in mathematics or statistics, I've had 1 or 2 postgraduate students, one from Malawi, another one from Uganda. They contacted me and I was able to assist them in their postgraduate work, especially in their research work. My consultation for students is free. I don't charge any money when students consult me. I create my time to assist them because the essence of this YouTube channel is to share knowledge, is to contribute my quota in sharing knowledge across the globe. So if you have been watching videos from this YouTube channel and you have not subscribed to the channel, please subscribe to the channel. If you are a first viewer, subscribe to the channel, share my videos in your social media platforms, and as you do, God will bless you on every side. So permit me to claim my contact and my name as we go to the business of the day. Now, interpolation is a key topic in numerical analysis. Interpolation is a key topic in numerical analysis. We often come across problems on interpolation where the values of x are unequally spaced. For instance, the essence, if we are given n+1 data point that has x0, y0, x1, y1, x2, y2, down to xn, yn. These are data points, and we are to create or to calculate a polynomial from these data points or to calculate certain values. We normally use interpolation to do this. And part of the videos I have in my YouTube channel, 2 of the topics were for interpolation, where we use the Newton's forward difference formula and the Newton's backward difference formula to solve problems on interpolation. Those problems, the values for x were equally spaced. So we have values for h. The value for h is given because x were equally spaced. What if you come across a problem where the values of x are unequally spaced? The Lagrange's interpolation formula is one formula to use. It's one formula to use to polynomial or solve problems from such data points. Another formula that can be used is the Newton's divided difference formula, which is also called the Newton's general formula for interpolation. It's also called the Newton's divided difference formula. So, beloved, we shall be looking at this Lagrange's interpolation formula. If for parameter, or for instance, you are given data points as this x0 to y0 down to xn, yn, and you have to look for a value for y, you make use of this particular formula. If you have to look for a value for y from the data point, you make use of this formula. If you have to look for a value for x from the data point, you make use of this formula. So these are the two possible formulae to be used. Now, the best way to do this is to practicalize it by solving a particular problem. So what I'll be doing in this video, I'll be solving just two problems in this video, where I will use this formula where I'm looking for a value for y, and I will bring another problem, another example, where I will use this second formula where I will be looking for a value for x. So please wait patiently, watch this video to the end as you see how the Lagrange's interpolation formula can be applied, how it can be used when the values of x are unequally spaced. I will explain what that means. Now let's go quickly to the first example. We can call this example 1. Now the example says certain corresponding values, certain corresponding values of x and log x to base 10 are, these are the values. The first one we have 300, comma, then when you take the log of 300, you have 2.4771, you close it. Then the second one is 304, then the value is, for log 304 is 2.4829, then the next one is 305, then log 305 is 2.4843, and 307, then the log of 307 to base 10 is 2.4871. Now the question is find log 301 to base 10 from this data point. Now you can see, now when we look at this particular problem, the value of x, of course this problem is given in this nature, x and log x to base 10. That is how it is. So when you see 300, you have log 300 to base 10. You see 304, log 304 to base 10. 305, log 305 to base 10. 307, log 307 to base 10. Now we are now told to find log 301. Are you getting me now? So now what you are going to, the question is this: you have 301 and of course is the value log, of course. Now you can call this one the question mark. That means what we are looking for here, we are looking for the value for y. So the, of course this is likened to be x, comma y. These are the data points. These are the data points. So from here, now since we are looking for the value for y, of course log 301 of course is representing the value for y. So now where your x will be 301, so we can now apply this particular formula. If for instance we are given the value of y and we are not going to look for x, we are not going to use this particular formula. So please watch as we permit me to clean this other part of the formula, because this is not the one we shall be using since we are looking for the value for y. So just watch me as we go now. So now applying this formula, applying this formula is as simple as ABCD. I will come here, I will say log 301 to base 10 is equal to, if you have this, look at the way this particular formula, this is pi of x all over x minus xi, then pi prime of x as I runs from 1 to n. Of course, the yi is used to carry out the multiplication. Now let us start. You can know that from here our x is 301. So you will hold this first one. Look at what I'm going to do. You will hold this first one. Since our x here is 301, you're going to have 301 minus, I'm holding 304. I'm holding this first one, 301 minus 304. Then I will come now 301 minus 305, which is this one. Then I will have again 301 minus 307, which is this one. Of course, the pi prime, this is the first one that I held. What is the value for x here is 300. So I will now come here, I will now have 300 minus 304, then 300 minus 305, then 300 minus 307. So since I held this one, this my yi will now be this value. It will now be 2.4771. That is what you have there. Then you come here, you say plus. You see it now. You have held this first one. Now you are going to hold the second one. Of course, the plus is there. Then you come here. You now have this same, because our x is 301. You write 301 minus. Now we are starting from this one. We are holding the second one. 301 minus 300. Then 301 minus. We are now holding this one minus 305. We are jumping to this one. Then the next one will be 301 minus 307. Then this is the one we held down. The x value here is 4, is 304. So you come here, you now say 304 minus 300. You will be taking these values. Then 304 minus this 305. Then 304 minus 307. Now it is this second one that we held. It is this value of y we are coming to put here. So we are going to write it as 2.4829. You have that. So permit me to come and continue here. Of course, there is a plus sign here. It continues. So you are going to do it across. So permit me to remove this formula, because that is what we are applying. I hope you have written it out. And also permit me to remove this other part. So now that we have held this, we want to hold this. Of course, there is a plus sign there. So of course, okay, permit me to write the plus here. Plus. Now we are holding this third one. So of course our x is 301. So this will be 301 minus, we start from here, 300 into 301 minus 304. Then we are jumping this one, we are coming to this one. This will now be 301 minus 307. Then all over, which one are we holding? 305. So this will now be 305 minus 300. We are just taking this one. Then 305 minus 304. Then you cover the open. 305 minus this 307. Then since it's 305 that we use, we'll come and put the yi there, which is 2.4843. You cover it, then you put your plus sign there. When you put your plus sign there, you come here now. You are going to have, okay, let's rewrite it here. Then we are going to hold this last one now. So this will be 301 minus 300 into 301 minus 304, which is this one. Then bracket 301 minus 305. We cover the brackets all over. Then what do you have there? You have of course, is 307. So you now have 307, the one that we held down, minus 300. Then 307 minus 304. Then 307 minus 305. Then you cover the bracket. Then what is the y for the 307 is 2.4871. So when you have this, then from there you now begin to write. Now we have gotten this, we can now come and begin to write this as, now from this one, just take a note of this. Of course, 301 minus 304, you are going to have minus 3, 301 minus 305 minus 4, 301 minus 307, and so on and so forth. So permit me to okay, let me just write these two values out. From here, if you are going to write this, you have 301 minus 304, you are going to have minus 3, 301 minus 305, minus 4, 301 minus 307, minus 6. Then you put this value in, 2.4771. Then of course you put your plus. 301 minus 300 is 1. 301 minus 305, you have minus 4. 301 minus 307, you have minus 6. Then, okay, I'm going to clean this part. You put the denominator. The denominator is there. Okay, let's start again. 301 minus 304 minus 3. 301 minus 305 minus 4. 301 minus 307 minus 6. Then all over 300 minus 304 minus 4. 300 minus 305 minus 5. 300 minus 307 minus 7. And of course, this particular value is there. Then you come, you put your plus sign there. So permit me to remove this particular first side. So permit me to remove this side. Then, of course, permit me to remove this side also. So I can come here now and write that first one there. My log 301 to base 10 will be equal to, let me write that one first, minus 3 into minus 4 into minus 6 all over minus 4 into minus 5 into minus 7. Then you have 2.4771. Then of course you put your plus. Of course that second one, the second one will be 301 minus 300 is 1. Then you have 301 minus 304. 301 minus 300, you have that. Then 301 minus 305, you have minus 4. Then 301 minus 307, you have minus 6. Then all over the denominator. The denominator will be 304 minus 300, that will be 4. Then 304 minus 305, that will be 1, minus 1. 304 minus 305, that is minus 1. 304 minus 307, that will be minus 3. Then you put the value of y that we have there is 2.4849. 2.4849. 2.4829 rather. 2.4829. So you can see how we have that. We have minus 3, minus 4, minus 6. Then you have minus 4 minus 5 minus 7. Then you have 1 minus 4 minus 6. You have 4 into minus 1 minus 3. Then 2.4829. Then you come here, you put your plus. It's a continuation sign. Look at this one there now. Is there 301 minus 300 is 1. 301 minus 304 is minus 3. 301 minus 307 minus 6. Then all over 305 minus 300 is 5. 305 minus 304 is 1. 305 minus 307 is minus 2. Then of course you put your 2.4843. Then of course you put your plus sign. 301 minus 300 is 1. 301 minus 304 is minus 3. Then 301 minus 305 is minus 4. 301 minus 305 is minus 4 all over. 307 minus 300 is 7. 307 minus 304 is 3. 307 minus 305 is 2. Then you put this value 2.4871. You put it in bracket. Now, beloved, you can see how we have been able to go with this particular problem. We have these values. Then, if you carry out this expression, you are going to have log 301 to base 10. When you carry out this first arithmetic, you are going to get 1.2739. We are working with 4 decimal places. Then that is for this one. You multiply this. Of course, will give you negative. This will give you negative. Negative will cancel. Then you multiply by this. You are going to have this. Then you carry out this one too. You are going to have 4.9658 for this second one. Then the third one, when you carry that one out, of course, this one will give you a negative sign. Look at it here now. Minus will be plus. Of course, this minus will be there. So when you multiply this, divide it, and multiply with this, you are going to get minus 4.71 minus 4.471 4.44717. Then of course the third one will give you plus. Minus will be plus. So 3 times 4 is 12. Then 7 times 3 is 21. Times 2 42. 12 over 42 multiplied by that value, you will get 0.7106. That is what you are going to get. 0.7106. By the time you do this little arithmetic, by the time you carry out this little arithmetic, you are going to get 2.4786. So that will be the answer. Now you can check. Numerical analysis does not lie. It doesn't lie. You can check from your calculator. Check the value of log 301 to base 10, and that is 2.4786. Check it with your calculator. You will see that this formula, they are very, very dependable. They are very, very reliable. All you just need to do, carry out this arithmetic. You can see minus, this will be minus. Then minus will cancel minus. You will multiply, you get this. Do the second arithmetic, you get this. The third one, of course, will get negative. The last one, you get this. And you carry out the arithmetic with your calculator, you should be able to get this. So, and again, if you want to test how efficient this Lagrange's interpolation formula works, you will see you can use your calculator to check out for the answer. So beloved, this is the first example, getting the value for y. So you can come now and write this in this format. You can have your 301 comma, then you have 2.4786, because the question is, of course, log. It is in the form log x and log x. It's of the form x and log x. That is the form x log x to base 10. This is the format. This is the x coordinate. This is the y coordinate. So because they are data points, so we have been able to resolve that. So Beloved, let us take another example where we can use the second Lagrange's interpolation formula to solve for a value of x. Now we want to see, now we have been able to use it to solve for a value of y. What you just need to do, you interchange the two variables. You interchange it. When x is interchanged for y, you get the other formula. When y is interchanged for x, you get the other formula. So now, whichever one you are looking for, it is quite possible for you to get it out. So for those of you who have subscribed to this channel, the essence of the channel is to share knowledge in key areas in mathematics and statistics across the globe. I want to thank you very much for sharing my videos on your social media platform. And for those of you who have subscribed, I am very grateful. If you are yet to subscribe, please try and promote this channel by subscribing. Click on the notification button, share the videos across your social media platform, and as you do, God will bless you. So now let's take another example where we have to look for the value of x. Now you can call this one example 2. Let's call this one example 2. Now for this example, if y subscript 1 equals 4, y subscript 3 equals 12, and y subscript 4 equals 19. You see this problem? So and y of x equals 7, and y of x equals 7. You see this? This one says find the value of x. It's as simple as that. Find the value of x. So what you need to understand when you are given a particular problem of this nature, you have to understand it because the data points are always given in the form xy, because it is interpolation. So we can write this particular problem, this can be written as, we can write this as, for this first one, the value for x there is 1. The right hand side is the value for y. Then for this particular one, the value for x here is 3. The subscripts are the value for x. Then the right hand side are the values for y. Then for this one, you have the value of x to be 4, the right hand side to be 19. And of course, for this particular problem here, you have x and you have the right hand side to be 7. And now the value that we are looking for is x. So the subscripts are the values for x. And you can see how we have been able to represent the particular problem in data as data points. So the value of x are unequally spaced. You can see it. Look at it here now. The difference, look at x here is 1, x is 3, x is 4. The difference between 3 and 1 is 2. The difference between 4 and 3 is 1. Like for instance, if I have a table like this, x, y, I have 0, 1, 2, 3, and I have 5, 9, 7, 8. You can see that the value of x here, they are equally spaced. Here your h is equal to 1. 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1. If you have another data set like this, x and y, where you have like this particular value, let me write it as you have 1, you have 3, you have 4, and here you have 4, you have 12, and you have here 19. You can see here now that the difference between 3 and 1 is 2. The difference between 4 and 3 is 1. So here the values of x are not equally spaced. They are unequally spaced. So for this kind of problem, we use the notice forward or backward difference formula. Then for this particular problem, we use the Lagrange's interpolation formula when the values of x are unequally spaced. I hope you have gotten this message. So this problem now, the values for x here are unequally spaced, so we can use the Lagrange's interpolation formula. So and the right formula to use is the one we use to get the values of x, which is x equals, of course it goes like this summation, I is equals to 1 to n. Of course here now you are going to have pi of yi, then all over y minus yi, then of course your pi prime of yi, then of course you have your xi there. That is how this one works. So this is what we use to get for the values of x. Now let us go ahead. So here, solving this, we have our x will now be equal. Look at the way it is done. Now what is the value of y for the unknown x? That is 7. So that is what we are going to use all through, but we will hold this first one first. So we are going to have, we will hold this first one the same way we held this, the other one when we're dealing with the other formula. So you are going to say 7 minus, of course, it's the values of y you are using because it is pi of yi. So the first y there is 12, 7 minus 12. Then of course bracket open, 7 again minus, of course the second one is 19 minus 19. Then all over, what is our the one we held down here is this first one that we didn't use. And what is the value for y for that one? The value for y there is 4. So this one will now be 4 minus 12, bracket open, 4 minus this 19. Remember we are putting our xi. So we are putting our xi for this one we held. This one we held, the xi is 1. That is what we have. That is the value of x there is 1 for that first one. So you go again and add because the summation runs from 1 to n and the data points are x0, y0 down to xn, yn. Now that you have held this first one, you are going to hold the second one. You are still using the value of y, which is 7 minus, now the value of y here is 4. Then of course we will jump the second one because we held this first one. We are going to hold this one now. Then into 7 minus the value of y there is 19. Then all over this one that we are holding, what is the value of y that we are having there is 12. The value of y that we are holding here is 12. You can see the value of y, this is the one we held down. The value of y is 12. So you come here, you have 12 minus this 4 that you have here. Then bracket will be 12 minus, of course, this 19 that you have here. Then now you now put the value of x for this one that you held down. What is the value of x that we held down? Is 3. You put it down there. Then you come again, then you are going to have plus. Look at this one now. We have held this one down. We held this one down. It's time to hold this particular one down. So you come here now. This will be 7 because this is the value of y for the unknown. So it's 7 minus, of course, the first y here, 7 minus 4 into the next one is 7 minus 12. Then all over. Which one do we hold down? This one is the one we held down, and the y value is 19. So this will be 19 minus this 4, then bracket 19 minus 12. Then the one we held down is this one. And what is the value of x for it? The value of x for it is 4. Then you put the 4 in bracket. That is what we have been able to achieve. So coming here now, you have your x is equal to 7 minus 12 is minus 5. 7 minus 19 is minus 12. All over 4 minus 12 is minus 8. Then, of course, 4 minus 19 is minus 15. Then, of course, you have bracket 1 plus 7 minus 4 is 3. 7 minus 19 is minus 12. All over 12 minus 4 is 8. 12 minus 19 is minus 7. Then of course you put the value of 3 there. Then plus 7 minus 4 is 3. 7 minus 12 is minus 5. All over 19 minus 4 is 15. 19 minus 12 is 7. Then you put the value of 4 there. Now we are going to solve this in terms of fraction. Now when you have 5 times 12, of course, minus 5 times minus 12 is plus 60. Then minus 8, minus 8 and minus 15 is 60. So you have x is equal to 60 all over 120. Then you put your plus. Of course, you come here, 3 times 12, 3 is minus 36 times 3. Of course, you are going to have 108. That minus will cancel this minus. You have 108 all over 8 times 7 is 56. Then, of course, you come here plus. Of course, this will now be minus 5 times minus 5 times 3 is minus 15. Minus 15 times 4 is minus 60. Of course, the denominator does not have a negative sign. 15 times 7 will give you 105. So that will definitely give us 60 over 120 is 1 all over 2 plus 108 over 56 will give you 27 over 14. 27 over 14, you take it to its lowest term. Then of course, when you divide this one, 60 over 105 will give you minus 4 over 7. And when you carry out this arithmetic, our x will be equal to 1.86. This will be 0.5. You take the fractional part and do the arithmetic. Now the actual answer, the actual value is 2. The actual value of x, is 2. But you can see that up to 2 decimal places, or we can approximate to the nearest whole number, which is 1.86 can be approximated to 2. So x, this simply means that x is equal to 1.86 can serve as an approximation. Can serve as an approximation. So you can see the beauty of numerical analysis. The actual value, because you can see here the value of x is 1, here the value of x is 3, here the value of x is 4 to their whole number, and here now is approximately 1.86 that the numerical method got for us, which is approximately 2, because they are whole numbers, so you round it up to the nearest whole number. So 1.86 can serve as can be used as 2 when approximated. So you can see the value of numerical analysis, how we have been able to use the Lagrange interpolation formula when the values of x are not spaced equally, when they are unequally spaced. When it comes to interpolation, here we have been able to use the formula of y, and we'll also be able to use the formula of x. So depending on which of the value you are looking for in the data set, you know, the data set has x coordinates and it has y coordinates. They are coming in pairs from x0, y0, x1, y1, x2, y2 down to xn and xn, yn. So you can see that this Lagrange's interpolation formula have been able to assist us in finding value for x or y when especially the value of x is unequally spaced. Beloved, I thank you very much for watching this video patiently to the end. For those of you who have subscribed to my YouTube channel, I say a very big thank you to you. And for those of you who are yet to subscribe, please do subscribe to the channel, and as you do, God will bless you on every side. Like as I said, the essence of this channel is to share knowledge in key areas in mathematics and statistics, preferably numerical analysis and applied statistics. I am an expert in numerical analysis and applied statistics. That is my area of specialization. I've been lecturing courses in these areas for the past 18 years as a professional in the polytechnic system, in the university system, and in the college system here in Nigeria. So I have worked with 2 AI firms in the United States of America, where I assisted in training AI models, and I've also assisted some postgraduate students from Malawi and Uganda. So if you are a postgraduate student feel free to contact me. You will see my contact and my email address at the beginning of this video. Share your challenges with me and I'll be able to render 1 or 2 assistance to you. It is free of charge for students at all levels. And if you have challenge in any topic in numerical analysis or applied statistics that have been giving you challenges, you can put it in the comment section so that I will be able to maybe create a video or do a video on it and upload it for your sake. God bless you. Thank you very much. Enjoy the rest of the day. Bye.